Alright, let's begin. So I'll go through a quick revision first of what I taught you all yesterday, and then we'll continue with how we name these compounds. Alright? Alright, so first of all, let's start off with this page. So we have our homologous series on the left hand side, which are alkanes, alkenes, alcohols, and carboxylic acids. You need to remember that for alkanes, the name's ending will always be "ane". For alkenes, it's going to be "ene". For alcohols, it will be "ol", "ol". And for carboxylic acids, the ending name will always have a oic acid written and at the end. For example, methanoic acid, ethanoic acid, propanoic acid, butanoic acid. For alcohols, we'll have methanol, propanol, butanol. For alkenes, we'll have ethene, propene, butene. And for alkanes, we'll have methane, ethane, propane, butane, octane, heptane. Got it? Then I taught you guys about how we set up the general formula and the structure for our alcohols over here. This was the part that we did then. So see, for propanol, what did we do? First we attach OH, just write OH, and then on the left hand side we write down our radical part, that is this. So for example, if I want to make propanol, I know prop means 3 carbons, so first I make 3 carbons, then I attach OH at the right hand side, and then I just fill up the empty spaces of carbon with hydrogen. And same is the case for butanol and ethanol. After this, we studied about carboxylic acids. What I taught you all over here was that for carboxylic acids, the number of carbons will always be one less that we were taking generally for alkanes, alkenes, and alcohols. For example, if I need to make methanoic acid, so meth means 1 carbon. So instead of writing 1 in place of N in our formula, we will be writing 0, 1 less. So for example, methanoic acid means 1 carbon. But if I use the general formula for methanoic acid, the general formula for methanoic acid is CN H2N plus 1 and then COOH. So over here, for example, if I take N equals to 1, what would happen? I write 1 over here, and then 2 into 1 is 2, 2 plus 1 is 3, so it would become CH3COOH. If I count the number of carbons over here, I can see there are 2 carbons. So 2 means propanoic acid. This would become wrong. So for methanoic acid, the number of carbon will be 1 less always. If you want to make methanoic acid, I won't be taking N as 1, I will be taking N as 0. So in this case, how would it look like? Cn. N over here is 0, so this becomes CO. H2N plus 1, and again over here becomes 0. And then plus COOH. As this was 0 over here, this is cancelled out. 2 zeros are 0, 0 plus 1 is 1. So only hydrogen is left over here. That's written in this place. So for the formula for methanoic acid becomes HCOOH. And then the functional group of methanoic acid is this. We will always have a double bond with the oxygen and a single bond with hydroxyl like OH over here on the right hand side. And then on the left hand side, whatever is left over here, we just write those things over here. In this case, we do not have any more carbon chains, only hydrogen is there, so we just place hydrogen over here. See, all the empty spaces are filled for carbon. It has 4 bonds, 1, 2, 3, 4. In the same way, we studied about ethanoic acid. So for ethanoic acid, instead of writing N as 2, we will take N as 1. When we take N as 1, this is what it will look like. CH3COOH. And here is the structure for ethanoic acid. And then we also did propanoic acid. Again, see, instead of writing C3, we write C 2 over here. And then 2 twos are 4, H5C2H5COOH is propanoic acid. Do you get this part? Alright. After this, yeah, this was it. This is what we studied yesterday. Now, this part, I was telling about this. For butene, this is just a general name for this compound over here. We just wrote butene. But if I say that name this compound, we know it is butene, but which butene is it? So, we always start counting from the part where the double bond is nearest. In this case, if I start counting from here, the double bond is very far away. If I count from the right hand side towards the left, in this case the double bond is near. So I will be choosing this side over here, the right hand side. I won't be choosing the left hand side. So if I count like this, then it would become, this is the first chain of carbon, second chain, third chain, fourth chain. So on which chain is the double bond? The first chain. So what do we write? We write but 1 ene. 1 over here is representing and telling us that where do we have our double bond in the carbon-carbon chain for alkenes. Do you get this part? Okay. Then for butene, but-2-ene. Why do we call this but-2-ene? If I start counting from the right to the left, it would be 1, 2, 3, 4. In this case, this is coming at number 2. If I start counting from left to right, then what would happen? 1, 2, 3, 4. Again, it's coming at number 2. So the chain, no matter I go from left to right or right to left, in this case, the double bond will always be on the second chain. So therefore, it is known as but-2-ene. Got it? Okay. Let's draw propene now. So for propene, how many carbons do we have? Oh, not propene. Let's make heptene. Heptene has 5 carbons. So 1, 2, 3, 4, 5. We are making heptene now. So 5 carbons. Yeah. Sorry. Oh, I am so sorry. Yes, heptene is 7. My bad. My bad. Pentene. Okay. Yeah, right. We are making pentene. So 1, 2, 3, 4, 5. Now let's give me the branch number. Where do you want me to place the double bond? In the middle? Where in the middle? Over here or here? Okay. So let's make the double bond here. There we go. Let's make the carbon atoms now. Sorry, hydrogen atoms. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. I'm writing it here. 4. 1, 2, 3, 4. 1, 2, 3, 4. What do I get here? All my hydrogens. H, H, H. So here we go with our hydrogen. This is what pentene looks like, but if I name it, what should be the name for this one? Where should I start counting? Should I start counting from left to right, or should I go from right to left? Very good, very good. We will go from left to right because it is the closest to get to the double bond from left to right. We will get to the double bond at 1, 2, the second branch. And from here, 1, 2, 3, or at this third chain, we are getting double bond. So therefore, we'll take this side, not this one. So in this case, what will be the name now? Pent 2 ene. Very good. Got it? Any confusion till here? Alright. Now let's 1 minute beta. Have a look over here. This is very important. So see here. Yeah. Okay, okay, yeah, take your time. So have a look over here now. The difference between the molecular formula and the structural formula. This is very important part. So you all don't make mistakes in this in the exam. Have a look here. We have ethane over here as an example in this case. See, when they're asking us to write down the molecular formula of ethane, we write C2H6. Simple. Correct. But when we are forming the structural formula, it is CH3CH3. How did we get CH3CH3? Any idea? Think of it. By that time, I'll draw the structure of ethane for you. Okay. Very good. Exactly. So, see, if you'll forget how it should be, all you need to do is just draw the structure first. Once you have drawn the structure, then just break down each carbon along with its bonds like this. Got it? So this here gives me CH3 and this also gives me CH3. So this becomes the structural formula for ethane. Understood? Let's draw propane now. Hmm. Yes, we are just arranging it. We are just letting the reader know that how are these bonds connected to each other basically. Now, what do we need to connect with each carbon basically? This is what we are telling through the structural formula, that how does the structure need to be represented. So for example for propane, so see 1 2 3 and then here hydrogen, 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 hydrogen. So how do I let someone know that first I need to make CH3, this thing? Alright, CH3. First we have CH3, then what do we have? Then we have CH2. And then again we have CH3 again. So this becomes the structural formula. Okay. Now one more thing. Let's check out. Give me a name. Which one do you want me to draw for you? And let's see how do we draw the structural formula for it. Give me any name from this table. Propanoic acid. Okay, let's do it. So propanoic acid. Propanoic acid means what? C2H5 and then COOH. Correct. If I draw the structure first, what I need to do is I need to show that C double bond here. Yeah. And then OH here. Correct. Now on the left hand side we have to draw the rest of the carbons. That would be, so propanoic acid means 3 carbons. So one is already here, second one, third one. Now I draw the hydrogens here, 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 and then again here. Got it? So this is the structure of propanoic acid. Now let's break it down. This part, and then this part. What would we get? CH3, yeah, CH2, and then COOH. Yes, got it? Here it is, propanoic acid. Understood? When they ask you to draw, yeah, I can do. Which one? propene. Yeah, okay, let's do propene. So propene means three carbon atoms. One, two, three. Now it is in my hands where I draw my double bond for propene. Where do you want it? On the right or on the left? Okay, let's make it on the left. They have drawn it on the right, I'm making it on the left. Or 1 minute, I'm making the same structural formula that they have represented over here. Okay, so this one is representing my double bond on the right. So what will I do? I'm gonna make the double bond on the right. One, two, three. The double bond is on the right. So hydrogen here. One, two, three, four. One, two, three, four. One, two, three, four. Hydrogen, 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 hydrogen. Carbon cannot have more than four bonds around it. Okay. So let's now break it down. This and then this and then this. Yes. What is this? CH3. What is this? CH. What is this? CH2. Just note this thing. We have a double bond between these two carbons, correct? So, for alkenes, do not forget to mention the double bond between them. Okay? Always for the double bonds are always represented in the structural formula. Okay, it's not necessary for the molecular formula as you can see over here. Sorry, this one and this one. But you have to represent it always in the structural formula. Okay, 1 minute. You all right? So, any questions now? You got this? All right, very good. Let's now have a look at this part. See, these are two different alkanes, but their molecular formula is the same. See, this is C4H10. This is also C4H10, right? But look at the structure now. Have a look at the structure. They are calling this one butane, and this one is known as 2-methyl propane. So, this is a straight chain carbon formula. As you can see over here, butane is what? 1, 2, 3, 4. It's simple structure, right? Let's talk about this one. 2-methyl propane. So methyl is a part of the alkyl family. Alkyls, these are radicals. They go like this: CH3, C2H5. It's basically the formula for them is CnH2n plus 1. Okay, so for this part they are saying 2-methyl propane. I'll teach you how to draw this. If this name is written over here, how do I draw this now? First, I draw the main chain. What is this? Propane? Yeah. So I'm going to draw propane first. Propane is 1, 2, 3 carbons. Yes? 3 carbons. Then they are saying methyl. And the number they are presenting over here is 2. What do they mean by this? This means that we have a branch of methyl attached on propane at number 2 on the second chain. That means not over here. This is 1, this is 2, this is 3, right? We always count from the nearest chain. So this is the middle one. I have to make methyl over here. Got it? On number 2. I either draw it above or below. It does not matter. In this case, I am drawing it in the center. Alright, so over here I'm going to draw methyl now. So I told you methyl is CH3, ethyl means C2H5. So for methyl I'm going to write C here. Okay? I'll change the color for it. C here. And the hydrogen for methyl is this part. So this becomes my methyl here. Okay. Now all I have to do is just attach the hydrogens for my propane. How would I draw it? One bond, second bond, third bond, fourth bond. Okay, and then over here, one, two, three, and fourth is already there. So hydrogen here, hydrogen here, hydrogen here, hydrogen here, 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 and here. Okay, I'll set up the pictures. Give me a second. Here's my hydrogen. Okay, so this is all propane, and at the second chain I have my methyl. So I'm drawing methyl like I'm just extending the chain over here like this. Got it? So this is methyl. This part is methyl, and the rest of the part is propane. And as methyl is at number 2, so we are saying it is 2-methyl propane. Now let's assume I remove my methyl from here. I draw my hydrogen here, and then I draw CH3 here. I write CH3 here, or I simply make 3 hydrogens over here like this for this carbon. Now what would I name this? Now this would be called 1-methyl propane, or just methyl propane. Got it? Okay. So do not forget about the straight main chains. The straight main chain over here was propane. For this butane, the straight chain was this 4-carbon chain. For this, we had a 3-carbon chain. No, it can be from right to left. It's not necessary. In this case of propane, no matter you go from left to right or right to left, it will be at number 2 in this case when we are making 2-methyl propane. Okay. What? Hmm, like for this part, for this only? Yes, yes. Yeah. Yeah. Basically, we won't have 3-methyl propane in this case anywhere, because if I move my methyl on the right hand side, then I'll have to count from the right hand side. Okay, if I have drawn my methyl over here, I'm going to count from here like this: 1, 2, 3. This will be 1-methyl propane. If I move my methyl from here and I shift it to the right like this, now I'm going to count from here: 1, 2, 3. Still, this is going to be 1-methyl propane. It won't be 3-methyl propane. Got it? In this case scenario. Understood? Okay. What else we have to do now? Alright, these are not the same. They both are very different from each other. Understood? Let's move on now. Let's move on. You need to learn this part, okay? What are homologous series? Uh, It is a series of organic molecules having same functional group, same general formula. The members that differ from one to next by CH2 unit, a consistent trend in the physical properties with increased molecular size and similar chemical properties. Got it? Do not forget them. I showed you the homologous series. They were what? Alkanes, alkenes, alkynes, alcohols, carboxylic acids, all of them belong to are part of the homologous series, and their functional groups are different. Alkanes have different, alkenes have different, alcohols have different. Got it? Now, have a look at this part. What is isomerism? What are structural isomers? What is structural isomerism? This is what we will be studying now. I just showed you an example that we just did. What was it? We had butane, C4H10, yeah, and then again we had C4H10 written, but in this case we had what? 2 methyl propane, and in this part we had butane, right? Both of them have same molecular formula. Yes or no? Right. Okay. As they have both molecular formula, but their structures are different from each other, which makes them very different from each other as well. They are not the same anymore because their structure is different. Do you get this point? Okay. So what I can say over here is that their molecular formula is same, but the structural formula will be different, correct? Structural formula will always be different when I draw them out. So this thing over here is known as our structural isomerism. Why am I calling them isomers? Do you remember what does isomer mean? Okay. So this is known as structural isomerism. So in the exam, if they ask you to draw isomers of butane, what would you do? You can make butane and then you can use the same molecular formula and draw a different structure to represent a different molecule, a different compound. For example, 2-methyl propane. This is a totally different structural isomer. This is a structural isomer. This is also a structural isomer. If I want to draw another structural isomer, I can make just 1-methyl propane as well. Yes, I can make 1-methyl propane. Got it? So these are called what? These are the structural isomers of each other. And this whole thing over here that is in front of you, this is known as our structural isomerism, in which the property of the compounds have the same molecular structure, the same molecular formula, but they have a different structural formula. Got it? That's it in this part. I taught you already about this, remember? See, butanene, butene. So if they ask you in the paper, draw structural isomers of butene, what will you simply draw? You will draw butanene for them, and then you will draw butene for them. This will give you the marks that you were seeking for. Easy. So these are our structural isomers of butene. What are the structural isomers of butene? Butanene, butene. You can't have butene in this case. Why? Because see, no matter what I do, I'll end up at the longest chain, at the end part only. So I can either get butene or I can get butene over here. If I take this bond to any corners, I'll have to write butene. Look. Hmm. Yeah, let's draw pen. We can, yes, exactly. We can make 3 for pentene. Let's do it, okay? I'll draw it over here. So what we are doing over here is we are making structural isomers of pentene now. So pentene means what? C5 and H10, right? Yeah, let's do pentene. Instead of pentane would be very easy. Let's do pentene, okay? One more thing. Yeah, let's do pentane. I'll give you another worksheet to solve for isomers as well for the homework. So let's begin. 1, 2, 3, 4, 5. Where do you want me to attach the double bond? Let's say over here first. Okay. If this is the case, what would be the name for this one? Let's say all these are hydrogens. I'm not writing hydrogen, but you already know that all these are hydrogen. Okay. So what do I name this? This would be called what? Pent 1-ene. Yeah. Let's let's draw another isomer. You technically don't need to write the yeah yeah, but you are representing the isomer over here, so that's why you have to write it. Okay. Let's move the and I'm very sorry. I attached this here. 1, 2, 3, 4. Yeah. Okay. Now let's move our double bond to the right here. In this case 1 2. Okay, I have to move this as well from here. So 1 2 3 4, 1 2 3 4. Yeah, others are correct. What do I name this now? I'll count from the left to right because the double bond is more closer from left to right rather than right to left. Okay, so this is going to be known as what? Pent 2-ene over here. Okay, now do you think we will get pent 3-ene over here? Yes. Why? Because see, if I now move this to the right, then I'll have to count from right to left. Because then what would be the case if I'll be counting from left to right? It would be at number 3. But when I'm counting from right to left, it will be at number 2. So I'll have to choose the right hand side then. And again, it will be named as pent-2-ene. If I move this double bond from here to this side now, in this case, still this would be called what? Pent-2-ene. It won't make a difference. In the same way over here, if I move this double bond from here and I put it over here, still it will be called what? Pent-1-ene. Got it? Okay. Let's try heptene. So for heptene, all I need to do is just 7. So 1, 2, or let's draw hexene. 1, 2, 3, 4, 5, 6. So we have hexene over here. Let's draw the double bond. If I draw the double bond here, would it matter if I count from left or right? It will be 3 either way. It would be what? Hex 3 in this case. Yeah? Hex 3 in. If I count from here 1, 2, 3. See? And then here's also 1, 2, 3 again. So hex 3 in. Let's move this from here to this part. Now what do I call this? Yes, now it's going to be called hex 2-ene. If I move from here to this part. Now it will be called what? Hexguanine. Very good. If I say I need to draw another hexguanine, then what do I do? Then I move this from here. Yes. And I put it over here. Still it is called what? Hexguanine. Got it? So I hope you will be able to draw all the isomers they asked you to draw for the paper. Yes, they will. They will. So you have to properly memorize the definition for the isomers as well. I'll attach them in the frame for you guys. Okay. Do you want me to draw one isomer that would look like this one that we just solved earlier, like 2-methylpropane? Let's do something like that. Okay. So that it's more clear to you guys. Let's draw one for pentane. Okay. So pentane would be like this: 1, 2, 3, 4, 5. So formula for pentane is what? C5H12. Got it? Now, how about one is general pentene? Let's say this is pentene. Pentane, sorry. This is pentane. Okay, yeah. One now see what I'm drawing. 1, 2, 3, 4, 5, and these are my hydrogens. Okay. What do I name this? What do I name this? This would be called what? Pentane. Yeah. What will I name this? See this branch? This is my methyl. So where is it? 1, 2 at second chain. So I'm going to name this 2-methyl and then the straight chain. Now you look at the straight chain. Don't look at the branch now anymore. So how many carbons do you see here? 1, 2, 3, 4. Yes. So it's going to be called 2-methyl butane. This is an isomer of pentane. 2-methyl butane is an isomer of pentane. Why? Because the molecular formula is same, but the structural formula is different. We have the same number of carbons and hydrogens in both the cases here. Okay. Let's in the same way. Let's draw another one. See now. 1, 2, 3. This time I'm doing carbon here and then another carbon here. Or 1 minute, not instead of here, I'm drawing it here. Carbon here and then another carbon here. So this becomes what? 1, 2, 3, 1, 2. 1, 2, 1 minute. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and then 4. Do you see this? Notice this part. This is my branch over here. Okay, now this is not methyl anymore. Methyl means CH3. Ethyl means C2H5. Are there 5 hydrogens over in this branch? There are 5 hydrogens, right? So how do I name this one now? This would be called what? 1, 2, 3. This is the main chain. So 3 means what? Propane. And then where is this is what? This is ethyl. This is not methyl anymore. So we have ethyl over here attached, and where is ethyl attached? On one or two? Where is ethyl attached? On the first chain or on the second chain? Second chain. So it's going to be called 2 ethyl propane. Got it? See, let's tally. We must have 5 carbons and 12 hydrogens in this case. Let's count, okay? 1, 2, 3, 4, 5. 5 carbons. Check. Let's count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Am I getting 12? Got it? So, isomers of pentane. Pen- this pentane itself, 2-methyl-butane, 2-ethyl-propane. All of them are what? Isomers of pentane because they have the same molecular formula, but see, their structural formulas are different. Got it? Hmm. It goes on methyl, ethyl, propyl, butyl. Okay. Yeah. Just remember these radicals. The formula for them is what? CnH2n plus 1. Got it? Okay, now see this. Now they are doing the same thing with what? Alcohols. They are naming them in this case. See, propane 1-ol, propane 2-ol. What does this mean? This means that the OH functional group is attached over at 1. In this case, it is attached at 2. Okay? I'll draw it. Propanol. Let's see what is propanol. Propanol means what? How many carbons? 5 or 4 or 3? How many carbons do I have in propanol? Very good. Prop means 3. And then we attach OH to represent that it is an alcohol. Yeah. If I draw it like this is named as, 1 minute, here. This would be over here named as what? Propan 1-ol. See, CH3, CH2, CH2OH. CH3, CH2, CH2OH. Got it? Any confusion till here? Okay. Now let's do propan 2-ol. See, notice the change that I make now. I'm removing uh, I'm removing this. I'm writing carbon again here. Carbon is attached with hydrogen here. And I'm attaching my OH over here. Now see what it is. CH3. Then what do I have here? Yeah. CH, and then in bracket you write OH. And then again CH3. In this case, where is my functional group? On the second chain? On either way, 1, 2, 3 or 1, 2, 3. Either I go from left to right or right to left. Both cases it's at number 2. So now in this case it's going to be called propan 2-ol. Got it? Okay. This is how you will be naming all of them. That's it. That's it for today. I'll continue this part tomorrow. Okay.